Good morning, grade 12s. This is a correction for the November 2018 question 3, the analytic geometry given to you as homework. Let's go through it. So we were given a diagram with k being -1, 2, and n being 1 and -2, and there's a point L on KP extended, and you have a point M which is -3, -5. That's going to be important for us for a later question. And they also give you an angle in space, and you have theta, which is an angle of inclination of the line KN. Now, an important thing to note, if an angle in space is given, that means angle not on the x-axis, then look for a triangle KP and this one here, and we could use that for a later question. Let's look at 3.1.1. Simple level 2 question. Find the gradient of Kn, 2 marks. We must get. We are given the 2 points. A recommendation: on your diagram sheet label x2, y2 and x1, y1 as the reference for the substitution into your formula, which appears on the formula sheet. Go slowly, substitute correctly. 2 minus -1. Be careful when you have negative, use a bracket. Over 1 minus 1, and you'll get the answer -3/2. Use a calculator, please. If you want to do this, use a calculator and type it out exactly. Let's not lose this 2 marks. That's almost 1%. Then the size of angle theta, the angle of inclination, or the inclination of Kn. So once again, we need the formula. Appears on your formula sheet. Tan theta is equal to the gradient of Kn. Firstly, note that tan theta is -3/2. Negative implies obtuse. Please note. And therefore, theta will be 180 minus tan inverse 3/2 positive, and you'll get your obtuse angle 123.69. Also 2 marks. We must learn this. So far 4 marks. That's genuinely at 1%. Please note this notion of an obtuse angle. The next question, 3.2, show that the gradient of KL is 1. Now KL does not have another point, so clearly we cannot use the inclination formula, that is gradient equals tan of an angle. So, but if you look at this triangle here, if you look at this triangle KP, and let's suppose this is S, KPS, then this forms an exterior angle of triangle KPS. Let's just extend that, and therefore 123.69 is equal to 78.69 plus alpha. Therefore, alpha will be the exterior angle. Subtract one of the known interior angle, and there's it here. Just state that it's an exterior angle that you're using, and therefore you'll get 45. Also, a little bit of thinking, must get those 2 marks. So the next question is also a standard question. Determine the equation of the line KL in the form y equals mx plus c. Another 2 marks. Grade 11 work. Remember, grade KL, we worked out that the gradient of KL is 45. So we have that angle. So we need to find the gradient. Now, what is missing here is how did we get that to be 1? So the gradient of KL is equal to tan of 45, and therefore gradient of KL is 1. So this must be included in your solution to tell the examiner that you calculated the gradient of KL. So therefore y is equal to 1x plus c. Now we need to find c. Look at the given point k, which is minus 1 and 2. So write it down like this: k, minus 1 and 2, x and y. Substitute in order to find c actually, and therefore c is equal to 3. Watch out the calculation, errors can creep in here. Therefore the equation is 1x plus 3. Do not forget to show this part. This is an important part that we need to go over. Now we want to find the length of Kn. So far, lots of level 2 questions. Write down the formula from your formula sheet correctly. Decide which is your x2, y2, and x1, y1. Preferably keep your 2's on top and your 1's in the bottom. Substitute correctly. Once again, use your calculator, and any one of the 2 answers are acceptable. So far so good. Question 3.5.1 will be done after we discuss circles in analytic geometry, because it's a level 4 question. If you notice, as you're going down the exam paper, the questions are getting progressively difficult. My recommendation for you in all your questions in grade 12 final examination, the first 3 questions, if you can answer the first 3 or the first 4, you are guaranteed a percentage of 45 and above. So make sure that you understand the level 1, level 2 questions and practice those, and guarantee yourself at least a 50%. Now in 5.2, they want us to determine the coordinates of L. If you look at the question in 5.1, you calculated L, but it says possible coordinates. So perhaps there's more than one value for L, more than one position of L, coordinates of L. But in this case, they want to be specific. Find the coordinate of L under these conditions, given that KLN is a parallelogram. So once again, it's the one that we discussed in our earlier video. Many methods, we could use transformations, or you could use midpoint, but I'm going to show you 2 different, an additional method. But let's look at this. So firstly, what you do is you want L, call that X and Y, and draw an arrow that you're moving from the unknown to a known. So you do the same here, K to N. Okay, when you have that situation, then you would normally use the distance formula, but only for the x's. X minus minus 3 is equal to minus 1 minus 1 in that order, and therefore x plus 3 is equal to minus 2. Therefore x is equal to minus 2 minus 3, which is minus 5. Very important. Be careful, can lend itself to lots of errors. The same thing with y, same order. Y minus minus 5 is equal to 2 minus minus 1, and therefore it's y plus 5 is equal to 3. Y is equal to 3 minus 5, which is equal to minus 2. Therefore L is minus 5 minus 2. The next method is the one that we used in our notes previously, is the one of transformation. So if I want to move from, how is a n transform to get k. So just be careful here now. Don't confuse the methods. Learn one method at a time so that we obviously have a strategy. Now you decide which one you prefer and use it. So in this case, we know that L is transformed in that direction. So from n to k, and therefore we go in that direction, from a known to an unknown. So if you go from n to k, then the rule will mean how can 1 become minus 2 if you add a minus 1? How can 1 become minus 1 if you add a minus 2? And check, 1 minus 2 is minus 1. Okay, if you substitute 1 here, so 1 subtract minus 2 is minus 1. How can minus 1 transform to 2 if I add 3 to it? And let's check. Minus 1 plus 3 will give you minus 2. So we got the rule. So the same thing, if I want to move from the known to the unknown, so minus 3 minus 5 for m going to L, which is we don't know. Therefore L would be minus 3 minus 2. Look at the rule. And minus 5 plus 3. Look at the rule. Will give you L to be minus 5 minus 2. A little bit confusing, a little bit of thinking, but some of us will prefer this over method 1. I like method 1 because it's much more easier to do. So your last question depended on us in getting t, which is from 3.5, which will be discussed in the classroom after we do circle. So t is minus 6 minus 3. Now they want us to find the area of triangle KTN. And KTN, firstly, we're going to use the area rule because we have an angle. We know that side which we calculated earlier. So therefore, let's calculate KT, the length of KT. Using the distance formula, be careful. You decide which is your x2, y2. So this is your x2, y2, and this is your x1, y1. Okay? And you substitute correctly. Watch the negative coordinates. In this case, there's double. Use your calculator exactly as it is, and you get the square root of 50. Therefore, the area of triangle KTN is equal to half times KT times KN times sine of angle K. And therefore, that is equal to half times square root of 50 times the square root of 13 times the sine of 78.69, and gives you an answer of 12,50 square units. And be careful how you apply your sine rule. Please note the integration. In this question, we use trig, we use geometry, we use angles of inclination, and all the important facts. Thank you. The video on circles will follow soon, most likely on Monday, but please go over these videos as a reminder and revision of what you have done. Thank you. Have a good day.